We are in chapter 1, numbers, quantification and numerical application. We are in the fourth concept related to pipes and cistern. In the previous lesson, in the previous class, we learned about the pipes filling up the tank. Okay. Let me recollect what we learned in the previous session. We are having a scenario in which this tank is filled by two pipes. One is A, the other one is B. If A takes XR to fill and tap B is going to take Y hours to fill the tank individually, then the part of the tank filled in 1 hour will be 1 by X by pipe A, and the part of the tank filled by pipe B in 1 hour will be 1 by Y. If they are going to be operated simultaneously, then the part of the tank filled in 1 hour will be X plus Y divided by XY. This is the part of the tank filled by the pipes A and B together, okay, in 1 hour. So, time taken to fill the full tank will be, we have to take the reciprocal. So, time taken will be XY divided by X plus Y. Suppose we are going to have 3 taps. Pipe A is going to take X hours to fill and pipe B is going to take Y hours to fill the tank individually, and pipe C is going to take Z hour. Then part of the tank filled by pipe A in 1 hour will be 1 by X, and by pipe B in 1 hour will be 1 by Y, and by pipe C part of the tank filled by pipe C in 1 hour will be 1 by Z. So, we take LCM now, it is X by Z. When we take LCM, it is YZ plus ZX plus XY. This is the part of the tank filled by all the 3 pipes when they are operated together. So, time taken will be X by Z divided by XY plus YZ plus ZX. In this case, in both the cases, the tank is filled by the pipes. There is no pipe attached to remove the water from the tank or the liquid from the tank. Now, take this situation in which tap A fill the tank in X hours and tap B is an outlet. It removes the liquid from the tank. It takes Y hours to empty. It takes Y hours to empty. Okay. If Y is greater than X, Y is greater than X. The meaning is the pipe B takes more time to empty the tank than the time taken by pipe A to fill the tank. So, in such case, the tank will be filled in after some time. After some time, the tank will be full. So, part of the tank which is filled by pipe A in 1 hour will be 1 by X, and the part of the tank which is emptied by outlet pipe B is 1 by Y. So, in such case the tank will be filled partly, it is 1 by x minus 1 by y. When you take LCM, it is y minus x divided by xy. So, time taken to fill the tank will be xy divided by y minus x. In the second case, the time taken by pipe A to fill the tank is more, x is going to be more. So, it takes more time, the pipe A takes more time to fill the tank than time taken by tap B to empty the tank. So, outflow is more faster than the inflow. So, what will happen? The tank will be getting emptied. So, part of the tank filled by pipe A will be 1 by x and part of the tank emptied by pipe B will be 1 by y. Here it is going to fill, pipe A is going to fill and tap B is going to empty. Okay. In such case, the part of the tank which is emptied in 1 hour will be 1 by y minus 1 by x. So, in that case x minus y divided by xy. So, time taken to empty the tank will be xy divided by x minus y. Now, in the other case we are going to have two taps which is going to fill the tank and one pipe is going to remove the water from the tank. So, pipe A takes x hours, pipe B takes y hour to fill the tank individually, okay, and the pipe C is going to remove water or the liquid. In Z hours. Okay. So, in that case the part of the tank filled by pipe A and pipe B will be 1 by x plus 1 by y, whereas the pipe C is going to eliminate. So, part of the tank which is eliminated or the liquid eliminated from the pipe C will be 1 by Z. So, this is the expression to calculate the part of the tank which is filled by the pipes when they are operated together, A, B and C together. So, in this session we are going to do problems of this similar type. In this session we are going to see the problems with a different category. Okay. Now, see this question. Two pipes A and B can fill the tank in 20 hours and 16 hours respectively. Now, we are going to keep pipe B open for 1/4 of the time and then after that particular time we are going to open both the pipes. Okay. Now, we are supposed to find the time required to fill the tank. We are supposed to find the time required to fill the full tank, okay, because it is going to be dealt with the two taps. We are having two pipes now. Time taken by pipe A to fill the tank. It is going to take 20 hours. Time taken by pipe B to fill the tank is time taken by the pipe B to fill the tank will be 16 hours. Both the pipes are not operated together. First we operate pipe B for 1/4 of the time taken to fill the entire tank. Okay. So we assume, let the time taken to fill the tank equal to T hours. T hours. Okay. Now part of the tank filled by pipe A in 1 hour will be 1 by 20 part, 1 by 20 part. Okay, because it takes to fill the tank 20 hours. So in 1 hour it will fill 1 by 20 part of the tank. Part of the tank filled by pipe B in 1 hour will be 1 by 16 part. Okay. Now we are going to take this total time T, we split this total time T into two parts. One is 1/4 of the time in which we are going to operate only pipe B, and the remaining 3/4 of the time we are going to operate both the pipe. Okay. So this is 1 hour. So the pipe B is going to operate for 1 by 4 of T. Part of the tank filled by pipe B in 1 by 4th of T. Hours will be equal to T by 4 into 1 by 16, that is equal to T by 64. Now for remaining part of time we are going to operate both the pipes. So how much part of the tank will be filled by both the pipes? Part of the tank filled by pipe A and B together, and they are going to operate it for 3 by 4th of full time required, 3 by 4 T, that is equal to 3 by 4 T of 1 by 20 plus 1 by 16. So we are going to find the sum. Okay, when you find the sum, the tank is going to be full. Okay, so it is T by 64. This is the part of the tank filled by pipe B alone, which runs for 1 by 4th of the entire time taken to fill the tank. We take LCM for the thing. Inside the bracket it is 3T by 4 into, we take LCM for this. LCM for 20 and 16 is 80. So in this 80, 20 will go 4 times. So we multiply that 4 with the numerator. 4 plus this is 5. 5 times 16 is 80. Which is equal to full tank 1. The tank is going to be filled. Okay. So this is T by 64 plus 3 into 9 T divided by 320 is equal to 1, which implies we take LCM now for 64 and 320. So when you take LCM for 64 and 320, it is going to be 320 will be the LCM. 64 will go in 320 5 times. So we multiply by 5. So 5T plus 27T is equal to 1, which implies 32T is equal to 320. So T is equal to 320 divided by 32. When you simplify, the answer will be 10 hours. So the time required to fill the tank will be 10 hours. Okay. Now let me recollect once again. The two pipes A and B fill the tank in 20 hours and 16 hours respectively. So pipe A fill the tank in 20 hours and pipe B fill the tank in 16 hours. We are not going to operate both the pipes together. First we operate pipe B for 1/4 of the entire time which is taken to fill the tank. Okay. We take the total time taken to fill the tank to be T hours. So it is going to be 1/4 time, 1/4 of the time. Okay. So the part of the tank filled by the pipe A in the 1 hour will be 1/20 part. Part of the tank filled by pipe B in 1 hour will be 1/16 part. So in 1 hour, the total part which is filled by A and B will be 9/80. Okay. When you take LCM and simplify, you will get this expression 4 plus 5/80, which is nothing but 9/80. And the tap B is going to be used for the first half, first part, 1/4 time. So it is T by 64. Next one will be 3T by 4 into 4 plus 5/80, which is equal to 1. When you simplify this expression, you get the total time to be equal to 10 hours. Let us see another problem. 3 pipes A, B and C can fill the tank in 72 minutes. So if the pipes A, B and C are going to be operated simultaneously at the same time, okay, it takes 72 minutes to fill the tank. Now we are going to operate all the 3 pipes together for 36 minutes. We are going to operate these 3 pipes only for 36 minutes and we are going to close pipe C, which means we are going to use only pipe A and pipe B. So if you are going to use pipe A and pipe B, it takes 1 hour more to fill the tank by pipes A and B. Find the time required to fill the tank by pipe C alone. Here we are going to find the time taken by the pipe C to fill the tank alone, we are going to find. Okay. So we have to analyze the question first. Okay. Here we are going to concentrate only on the time taken by the pipe C to fill the tank. Okay. But we have to start with the assumption that let the pipes A, B, C fill the tank individually in X hours, Y hours and Z hours respectively. That means A takes X hours to fill the tank and B takes Y hours to fill the tank and C takes Z hours to fill the tank. Then part of the tank filled by A, B and C in 1 hour is 1 by x comma 1 by y comma 1 by z respectively. So, if the pipe A alone is operated, it can fill the tank in 1 hour, will be 1 by x part of the tank. Is it clear? And it is given if all of them are going to be operated together, the time taken for the tank to getting filled will be, the time taken for the tank to fill will be 72 minutes. So, time taken by A, B and C together to fill the tank is 72 minutes. So, 72 minutes into 1 by A plus. So, we start the solution. We assume, okay, and the data given here are going to be in minutes. Okay, so we assume, let the pipes let the pipes A comma B comma C fill the tank in x minutes, y minutes and z minutes respectively. Okay. In such case, part of the tank filled by the pipes A comma B comma C in 1 minute will be 1 by x part, 1 by y part and 1 by z part respectively. Okay. So, when they are going to be operated together, part of the tank filled in 1 minute will be 1 by x plus 1 by y plus 1 by z. So, this much part will be filled in by the pipes A, B and C together when they are operated. Okay. Now, if they are going to be operated, the time taken to fill the tank will be 72 minutes. It is given. Okay. pipes A, B and C take 72 minutes to fill the tank. So, which implies 72 into 1 by x plus 1 by y plus 1 by z is equal to 1. We take this as first equation. Okay. Now, we are going to operate all the 3 pipes for 36 minutes and then pipe C is going to be closed after 36 minutes. Then we are going to use only the pipe A and pipe B, and we are going to make only these 2 pipes to make the tank to be filled. In that case, it takes 60 minutes more. So, we have to run the pipe A and pipe B for another 60 minutes to fill the entire tank. So, we write for 36 minutes all 3 pipes are operated. Then for next 60 minutes only pipe A and pipe B are used. To fill the tank. So, we write 36 into 1 by x plus 1 by y plus 1 by z plus for the next 60 minutes we are going to use only pipe A and pipe B. So, 60 into 1 by x plus 1 by y. Then the tank is going to be filled. Because it is going to be filled, we take that as 1 unit. Now, we are going to substitute for this value 1 by x plus 1 by y plus 1 by z. From the first equation, we get 1 by x plus 1 by y plus 1 by z is equal to 1 by 72. Okay. Now, we are going to substitute this expression. So, 36 into 1 by 72 plus 60 into 1 by x plus 1 by y is equal to 1. So, we cancel this term. So, it is 2. So, 60 into 1 by x plus 1 by y is equal to 1 minus 1 by 2. We take that 1 by 2 to the other side. So, we take LCM and simplify, it is 2 minus 1 by 2 which is equal to 2. Now, we get the value for 1 by x plus 1 by y. 1 by x plus 1 by y is equal to so, we take LCM and simplify, it is 2 minus 1 by 2. So, 2 minus 1 is 1 by 2. From this expression, we are going to get the value for 1 by x plus 1 by y. 1 by x plus 1 by y is equal to, we take the 60 to the other side. So, it is 1 by 2 into 60, that is equal to 1 by 120. So, when the pipe A and pipe B are going to be used to fill the tank, it will take 1 by, it will fill 1 by 120 part in 1 minute. Now, we take this expression and try to get the value for 1 by z. So, we are having the expression 1 by x plus 1 by y plus 1 by z is equal to 1 by 72. 1 by x plus 1 by y is 1 by 120. So, 1 by 120 plus 1 by z is equal to 1 by 72. So, 1 by z is equal to 1 by 72 minus 1 by 120. We take LCM for 72 and 120, the LCM will be 360. We take LCM now. So, in 360, 72 will go 5 times. So, 5 in 360, 120 will go 3 times. So, we multiply by 3 here. So, 1 by z will be 2 divided by 360, that is equal to 1 divided by 180. So, what is our conclusion now? Z is equal, 1 by z is equal to 1 by 180. So, z is equal to 180, that is pipe C takes 180 minutes to fill the tank when it is operated alone. Is it clear? Now, here we are having a different problem. Two pipes P and Q can fill the tank in 60 minutes and 30 minutes. So, this pipe P takes 60 minutes to fill the tank and Q takes 30 minutes to fill the tank. Is it clear? And now, the time taken by this pipe R to drain the entire tank is not given, okay, but they have given it is going to drain 5 liters of water per minute. It is going to drain 5 liters of water per minute. Here we are going to calculate the capacity of the tank. If all the 3 pipes are used, it takes 2 hours to fill the tank. This is an important data which is given to us already. If all the 3 pipes are opened, it takes 2 hours to fill the tank. We are supposed to find the capacity of the tank. Is it clear? Now, we start the solution. Time taken for pipe P to fill the tank. It is given to be 60 minutes. Okay. Time taken for pipe Q to fill the tank when they are operated alone will be 30 minutes. Okay. And we do not know the rate at which the pipe are going to drain the water from the tank. So, we assume time taken for pipe R to drain, to empty the tank will be x minutes. Is it clear? Now, part of the tank filled by pipe P in 1 minute will be 1 by 60 part. And same way, part of the tank filled by pipe Q in 1 minute will be 1 by 30 part. And part of the tank, it is going to be drained now by pipe R in 1 minute will be 1 by X part. And if all the things are going to be operated, the time taken for everything will be going to be 2 hours. It is going to take 2 hours to fill the tank. So 2 hours will be 120 minutes. Part of the tank filled by all the 3 pipes in 1 minute will be 1 by 60 plus 1 by 30. They are going to fill it. This third pipe is going to drain. So we have to subtract minus 1 by X. Okay. We take LCM and simplify this expression. This is 60 will be the LCM for these two terms. So it will be 1 plus 2 minus 1 by X, which is equal to 3 by 60 minus 1 by X. We cancel this term. So it is 1 by 20 minus 1 by X. Okay. Now it is going to take 120 minutes to fill the tank. Since it takes 120 minutes, to fill the tank, (120) into 1 by 20 minus 1 by X will be equal to 1. We take LCM now. (120) into X minus 20 divided by 20X is equal to 1. We cancel this 120. This is 6. That is X minus 20 divided by 6X is equal to 1, which implies X minus 20 is equal to 6X. So X minus 6X is equal to minus 20. So minus 5X is equal to minus 20. So X is equal to 4 hours. So X is equal to 4 hours. Okay. Now the question is not to find the time taken by the pipe R to drain the entire tank when it is operated alone. Our question is to find the capacity of the tank, and to calculate the capacity of the tank, they are given part of the tank filled by all the 3 pipes when they are operated together will be 1 by 60 plus 1 by 30 minus 1 by X. Now time taken to fill the tank will be 2 hours, that is equal to 120 minutes. So part of the tank filled in 1 minute will be 1 by 120. So we equate the first equation and this second equation. So we get 1 by 60 plus 1 by 30 minus 1 by x is equal to 1 by 120, which implies minus 1 by x is equal to 1 by 120 minus 1 by 60 minus 1 by 30. We take LCM, LCM will be 120. So, this is 1 minus 60 will go 2 times in 120. So, we multiply with the 2 in the numerator, minus 30 will go 4 times in 120. So, we multiply with the 4. So, which is equal to, when you simplify, the expression will be okay, minus 5 by 120. So, minus 1 by x is equal to minus 1 by 120, 5 by 120. So, we cancel this term. When you cancel, this is 120. So, we have here minus 1 by x is equal to minus 5 divided by 120. We cancel negative sign and we cancel 1 5s are 5, this is 24. So, which implies 1 by x is equal to 1 by 24, which implies x is equal to 24 minutes. Here we are not going to concentrate on the time taken by the pipe R to drain the entire tank. Our aim is to find the capacity of the tank, and they have given another data. R drains 5 liters of water per minute. Okay. So, in 1 minute 5 liters are drained. Therefore, in 24 minutes, amount of water drained will be 24 into 5, that is equal to 120 liters. So, 120 liters is the capacity of the full tank. In this problem, a tank is filled by 3 pipes with uniform flow. We are having 3 pipes. Okay. The first 2 pipes operating simultaneously fill the tank in the same time, during which the tank is filled by the third pipe alone. So, what is given in this sentence? Suppose A and B takes 10 minutes to fill the tank, then C individually will fill the tank in the same time, 10 minutes. Okay. The time taken to fill the tank by the pipe C will be same as the time taken by the pipes A and B together to fill the tank. Okay. And extra data are, the second pipe fills the tank 5 hours faster than the first pipe, which means the pipe B takes 5 hours less than pipe A to fill the tank. Okay. Suppose pipe A takes 10 hours to fill the tank, then pipe B will take 5 hours less than 10 hours, that is 5 hours to fill the tank. Okay. And 4 hours slower than the third pipe. So, third pipe is much more faster. Okay. We are supposed to find the time required by the first pipe to fill the tank alone. What is the time taken by the pipe A to fill the tank when it is operated alone? This is our question. Okay. So, we are given with two datas. One is the pipe A and pipe B take the same time as pipe C to fill the tank, and then pipe B is 5 hours faster than pipe A and 4 hours lesser than pipe C. Okay. Let the time taken by pipe A to fill the tank be x hours. Then time taken for pipe B to fill the tank will be x minus 5 hours. Okay, because it is 5 hours faster than pipe A. And pipe B is slower than pipe C, which means pipe C is faster than pipe B. So, pipe C fill the tank in 4 hours lesser than your pipe B. So, it is x minus 5 minus 4, which is equal to x minus 9. Is it clear? Pipe B is faster than pipe A by 5 hours and pipe B is slower than pipe C by 4 hours. So, when you write for pipe C, it is x minus 9. Now, A and B together going to operate. Part of the tank filled by pipe A and B together in 1 minute will be 1 by x plus 1 by x minus 5. By pipe C in 1 minute. Part of the tank filled by pipe A in 1 hour will be 1 by x and pipe B in 1 hour will be 1 by x minus 5. Okay. By pipe C in 1 hour will be 1 by x minus 9. Now, by the data given, A and B takes the same time as pipe C. Okay. That is 1 by x plus 1 by x minus 5. When they are operated together, it takes the same time as when pipe C is operated alone, that is 1 by x minus 9. Now we take LCM. So it is x minus 5 plus x divided by x into x minus 5 is equal to 1 by x minus 9. So we simplify this expression. 2x minus 5 divided by x into x minus 5 is equal to 1 by x minus 9. We cross multiply this expression. So when you cross multiply, you will get 2x minus 5 into x minus 9 is equal to x into x minus 5. We multiply. So 2x square, 2x into minus 9 minus 18x minus 5x, minus 5 into minus 9, it will be plus 45 equal to x square minus 5x. We bring all the term together. So it is 2x square minus 18x minus 5x. So it is minus 23x plus 49 minus x square plus 5x. This minus 5x is brought to this side, so it is plus 5x equal to 0. So 2x square minus x square will be x square, minus 23x plus 5x will be minus 18x Now we multiply 2x minus 5 into x minus 9, which is equal to x into x minus 5. So we multiply 2x into x, 2x square minus 2x into 9, it is 18x minus 5 multiplied with x minus 5x minus 5 into minus 9, it will be plus 45 equal to x square minus 5x. So 2x square minus 23x plus 45 minus x square plus 5x is equal to 0. So 2x square now we simplify this expression. 2x square minus x square is x square minus 23x plus 15x. When you simplify, it is minus 18x plus 45 equal to 0. Now we have to factorize this expression. Okay. X square minus 18x plus 45 equal to 0. On multiplication, we should get 45. On addition, we should get 18. So we factorize this expression, x minus 15 into x minus 3 equal to 0. So x minus 15 equal to 0, x minus 3 is equal to 0. So x is equal to 15, x is equal to 3. Okay. But x is equal to 3, not admissible. Why it is not admissible? If you take x is equal to 3, then time taken for pipe B to fill the tank will be 3 minus 5. It will be minus 2 hours. Your time cannot be negative. So we are neglecting this x is equal to 3 answer. So we conclude the solution by taking x is equal to 15. So the time taken by the pipe A to fill the tank is 15 hours. Okay, the first pipe. In this problem, 3 pipes A, B and C can fill the tank in 5 hours. So, when they operated together, it takes 5 hours to fill the tank. Pipe C is twice as faster than B and B is twice as fast as A. Okay. How much time will pipe A alone take to fill the tank? So, what is the time taken by pipe A to fill the tank alone? Okay. Here also it is given in terms of speed, okay, not time is given. Pipe B is twice as fast as A and pipe C is twice as fast as B. Okay. Now, if A takes 4 hours, then B will take only 2 hours and C will take only 1 hour. Okay. For our calculation to be simpler, we take the time taken by pipe A to fill the tank to be equal to 4x hours, okay, 4 times x. Then pipe B will take half the time only, okay, because it is twice fast as your pipe A. So, it takes half the time only. So, it is 4x divided by 2, which is nothing but 2x hours. And pipe C to fill the tank, it takes time only x hours. Is it clear? Part of the tank filled by pipe A in 1 hour will be 1 by 4x. Part of the tank filled by pipe B in 1 hour will be 1 by 2x part and pipe C in 1 hour will be 1 by x. When these 3 pipes are operated together, part of the tank filled in 1 hour when all the pipes are operated equal to 1 by 4x plus 1 by 2x plus 1 by x. Your LCM will be 4x. So, this is 1 in 4x, 2x will go 2 times. So, it is 2 plus 4. This is equal to 7 divided by 4x. Okay. And if all the 3 pipes takes 5 hours to fill the tank, then part of the tank filled in 1 hour will be 1 by 5. So, we equate these two equations. So, we equate 7 by 4x is equal to 1 by 5, which implies 4x is equal to 35. x is equal to 35 divided by 4. Okay. We got the value for x, 35 by 4 hours. Okay. We got the value for x alone, but the speed of pipe A, or the time taken by pipe A to fill the tank, by pipe A is 4 into x. So, 4 into 35 by 4. So, we cancel the expression. So, it takes 35 hours. So, when pipe A is operated alone, it takes 35 hours to fill the tank. So, here they have given pipe C is twice as faster than B, okay, and B is twice as fast as A. So, we take the time as 4x hours for A and 2x hours for B and only x hours for C to solve the problem. Now, in this problem, two taps A and B can fill a tank in 4 and 6 hours respectively. The pipes are opened simultaneously and it takes 6 minutes more to fill the tank due to leakage. If the tank is full, then find the time taken by the leakage to empty the tank. Here we are having two taps. Tap A takes 4 hours to fill the tank and tap B takes 6 hours. Then part of the tank filled by tap A in 1 hour will be 1 by 4 and part of the tank filled by tap B in 1 hour will be 1 by 6. Okay. So, we try to solve the problem with the given data. They are given tap A takes 4 hours to fill the tank. Tap B takes 6 hours to fill the tank. So, from this we get part of the tank filled by tap A in 1 hour. If it takes 4 hours to fill the tank, then part of the tank which is filled by tap A alone in 1 hour will be 1 by 4 part. And same way, part of the tank filled by tap B in 1 hour will be equal to 1 by 6th part of the tank. Now, when both are operated together, part of the tank filled in 1 hour when both are operated. Is equal to 1 by 4 plus 1 by 6. So, we take LCM. We are finding the time taken to fill the tank when they operated together. LCM will be 12. So, this is 3 plus 2. So, it is 5 by 12 part. So, time taken to fill the tank. Time. Here it is the part of the tank which is filled in 1 hour. We are going to find the time now. Fill the tank will be 12 by 5 hours. And it is in hours. So, we are trying to convert this one to minutes. So, we take LCM and when you simplify this expression, this is 5 by 12 hours. Sorry, 5 by 12 part. So, time taken to fill the tank by tap A and tap B will be equal to 12 by 5 R, which is equal to 12 by 5 into 60 minutes we take. So, this is 12 times. So, 12 into 12, 144 minutes it will take to fill the tank. Okay. Now, there is a leakage, a minor leakage in the tank. Okay. Due to leakage, the liquid is getting leaked, drained. Okay. Now, if the taps are opened together with the drainage, it takes 6 minutes more, 6 minutes more to fill the tank. Okay. Now, we write time taken for the minor leakage to drain the tank be x minutes. We convert to minutes now. Previously, we did it with hour, and in the final answer we converted to minutes. Okay. So, part of the tank drained by leakage. One by x part. Now, tap A is going to be operated, tap B is going to be there, and the leakage is also going to be there. When these three things are going to happen, then part of the tank filled in 1 minute. It is going to be 1 by 4. This is 4 hours, which is nothing but 240 minutes. This is 6 hours, which is going to be 360 minutes. Okay, because we have to convert everything to minutes. So 1 by 240 plus 1 by 360, okay, minus 1 by x. Is it clear? Now the tank is going to be filled with 144 plus 6 minutes, which is equal to 150 minutes. When these three things are going to happen, okay, it takes 6 minutes more to fill the tank. So the time taken to fill the entire tank now will be 150. So in 1 minute it will be filled with 1 by 150 part. Okay. Now we are going to take LCM. 720 is the LCM. So this is 3 times, and in 720 360 will go 2 times minus 1 by x is equal to 1 by 150. We simplify this expression. So 5 divided by 720 minus 1 by x is equal to 1 by 150. So we cancel this expression, we cancel this, 5 will go one time, this is 1 4 4, which implies minus 1 by x is equal to 1 by 150 minus 1 by 144. 150 into 144, we take LCM. 21600. Okay. Here it will be 144 minus 150, which is nothing but minus 6 divided by 21600. We cancel with the 6, so it is 1 divided by 3600. So we get the answer minus 1 by x is equal to minus 1 divided by 3600. So minus minus cancel, so which implies x is equal to 3600 minutes. When you convert this 3600 minutes to hour, it will be, you have to divide by 60, so it will be 60 hours. In this problem, a tank can be filled by 2 pipes P and Q. P takes 15 minutes and Q takes 20 minutes to fill the tank. Okay, A takes 15 minutes and B takes we change this one. Now we have a typical problem. 3 pipes A, B and C can fill a tank together in 2 hours. Pipe B and C take 3 hours to fill the tank, while pipe A and C takes 4 hours to fill the tank. Find the time taken by each pipe to fill the tank alone. Is it clear? Now the data given to us are A, B, C together. If they are going to operate, how much time it will take? It is going to take only 2 hours. Okay. If all the 3 pipes are going to be opened, okay, it will take only 2 hours to fill the tank. Suppose B and C are going to be used, we are going to use only B and C. If these 2 pipes are going to be used, then it takes 3 hours to fill. If A and C are used, if we are going to use only these 2 taps or pipes, it is going to take 4 hours. So with these 3 data, okay, we are supposed to find the time taken by the pipes A, B and C to fill the tank individually. The time taken by pipe A to fill the tank, we take this as x hours. Time taken by pipe B to fill the tank is y hours, and time taken by C to fill the tank will be z hours. Okay. So part of the tank filled by pipe A in 1 hour will be 1 by x, and same way by pipe B in 1 hour will be one by y. Pipe C in 1 hour will be 1 by z part. Now when all the three are going to be used, okay, when all the pipes are used, time taken is 2 hours. So part of the tank filled in 1 hour will be 1 by 2 part, that is 1 by x plus 1 by y plus 1 by z is equal to 1 by 2. Okay. Now we use the second case. B and C takes 3 hours, correct? Time taken by B and C to fill the tank 3 hours. Okay. That is part of the tank filled by B and C in 1 hour will be 1 by B, sorry, 1 by y plus 1 by z is equal to 1 by 3. This is second equation. This one we take it as first equation. Okay. Time taken by A and C to fill the tank is 4 hours. Okay. So part of the tank filled by A and C in 1 hour. This is 1 by x plus 1 by y is equal to 1 by 4. Is it clear? Now we are having 3 equations. One by x plus 1 by y plus 1 by z is equal to 1 by 2. Now substitute 1 by x plus 1 by y is equal to 1 by 4 here. In this expression, I am going to substitute 1 by x plus 1 by y is equal to 1 by 4. So, 1 by 4 plus 1 by z is equal to 1 by 2. So, 1 by z is equal to 1 by 2 minus 1 by 4. So, when we take LCM, it is 4. 2 minus 1, that is 1 by 4 part. So, part of the tank filled by Z alone will be 1 by 4 part in 1 hour. So, type taken by pipe C will be 4 hours. Next, same expression, 1 by x plus 1 by y plus 1 by z is equal to 1 by 2. We substitute the second equation now. 1 by y plus 1 by z is equal to 1 by 3. Here I am going to substitute. So, 1 by x plus 1 by 3 is equal to 1 by 2. So, 1 by x will be equal to 1 by 2 minus 1 by 3. We take LCM. 6 is LCM, cross multiply 3 minus 2, that is equal to 1 by 6. Okay. So, pipe A takes 6 hours to fill the tank alone. Now, we can substitute this 1 by x in any one of the equation here, or substitute the 1 by z value is equal to 1 by 4 here to get the value for 1 by y. Okay. We substitute 1 by x plus 1 by y is equal to 1 by 4. 1 by x is 1 by 6. So, 1 by 6 plus 1 by y is equal to 1 by 4. So, 1 by y will be equal to 1 by 4 minus 1 by 6. Take LCM. 24, it is 6 minus 4, that is 2 by 24. So, we get 1 by y is equal to 1 by 12. So, in 1 hour, the pipe B fills 1 by 12 part of the tank. So, time taken for pipe C to fill the tank will be by pipe B is 12 hours. So, pipe A takes 6 hours, pipe B takes 12 hours, and pipe C takes 4 hours. Here we are having another problem. Here one tap is going to fill the tank and 2 pipes are going to drain the tank. Okay. Now, the pipe A fill the tank in 3 hours time. Tap A is going to, pipe A is going to fill the tank in 3 hours. Okay. And the pipe B and C, okay, they are going to drain the tank, which is going to empty the tank. One is going to take 7 hours to empty the tank, and this is going to take 10 hours to empty the tank. When these 3 are going to be operated simultaneously, how much time it will take to fill the tank? So, pipe A fill the tank in 3 hours. So, part of the tank filled by pipe A in 1 hour will be equal to 1 by 3 part. Pipe B drained the tank. In 7 hours. It takes 7 hours to drain the tank. So, part of the tank drained by pipe B in 1 hour will be 1/7, and pipe C drain the tank in 10 hours. So, part of the tank drained by pipe C in 1 hour will be 1/10 part. Now, these three pipes are going to be operated simultaneously. So, if they are going to be operated, then part of the tank filled in 1 hour will be equal to 1/3. It is going to be filled, and the second pipe is going to drain, and the third pipe is also going to drain. Now, we take the LCM for 3, 7 and 10. Your LCM is going to be 210. So, in 210, 3 will go 70 times. We multiply with the 70 minus. In 210, 7 will go 30 times. So, multiplied with 30. And 210, 10 will go 21 times. So, we multiply with the 21 in the numerator. So, this is 70 minus 51 divided by 210, which is equal to 19 divided by 210 part. So, in 1 hour, 19 by 210 part of the tank will be filled by these operations. Therefore, time taken to fill the tank will be equal to 210 divided by 19. We divide 210 by 19. 119s are 19, balance 20, again 1 time 19, balance 1. So, it will take 11 hour. Okay, we convert this 1/19 into minutes. So, 60 divided by 19 will be 3.15 we are getting. We convert that 0.15 also to seconds. 11 hours, 3 minutes and 6 seconds it takes. Or in other words, you can write simply 11 1/9 hour. This is the final answer. So, in this session, we studied filling up of tank with 2 taps and 3 taps filling them, and 2 taps filling and 1 tap is going to drain the tank. Okay. Thank you, students.